In my last video, I showed my Guitar Hero demake project. It was an amazing experience where I drew pixel art, defined the game architecture, faced the challenge of creating a rhythm-based game, and put many Golang concepts into practice. After that, it was time to move forward. Most of my progress then wasn't about changing the gameplay, it was about changing how my future games would be built. The Guitar Hero game was a way to validate my Ebitengine boilerplate project, where my goal is to create a framework to easily build 2D games. It became a new challenge because the core of the project, which I call Firefly, don't ask me why, evolved, and I had to spend a lot of time refactoring the entire structure and project design. The biggest architectural change was splitting all the content into two modules, engine and game. All modular and reusable components live in the engine package. This package is immutable, treated as a read-only source of abstractions and core struct used as a base for game-specific implementations. The game module is where all game-specific files live and may contain optional example content. The purpose of this design is to enforce a clear boundary between core systems and application logic, keeping the engine stable while allowing the game layer to iterate freely. By treating the engine as a read-only dependency, I can version it and avoid accidental coupling with game-specific hooks. If you are familiar with Golang, you'll know that folder structure really matters in a project. Each folder is a package, and my older version of Firefly had many packages with too many responsibilities, especially the physics package. In that package, I had logic for shapes, body positions, character movement, and collisions. It was hard to work with and difficult to evolve. The refactoring approach was to turn physics into a module composed of sub-packages, each handling a specific responsibility. Body contains the core physics body definitions, including body, movable body, collidable body, and related components. Movement manages movement models, such as platform movement model and top-down movement model, along with general movement logic. Space handles the physical space where collision detection happens. Skill manages character actions and abilities, such as movement, jump, dash, and others. And speaking about the skill package, it was one of the most recent improvements that I did. Previously, character movement and player-specific actions, like jumping, were handled directly in the player loop. I moved both basic and advanced actions into skills. Now, a platformer character has skills that move based on input, jump when the player presses the jump button, dash when the player presses the dash button. This system also works for enemies, but without player-specific input. Their behavior can be driven by AI or predefined the logic instead. Regarding packages and modular design, I learned how organizing code into clear modules makes reasoning about the system easier and allows the project to scale more naturally. By grouping similar responsibilities through domain-driven refactoring, I learned how to create clearer boundaries and reduce coupling between systems. With composable behaviors related to physics and skills, I learned how to avoid large switch statements and God objects. I also put classic design patterns into practice, such as strategy, factory, composition over inheritance, dependency injection, states, singleton, and also learned why removing singleton is often a good idea. I'm not just making a game, I'm evolving the architecture of my codebase and putting advanced Golang concepts and complex design process into practice. Thanks for watching. If you enjoyed this video or found it useful, please leave a like, it really helps the channel. See you soon in the next video.